Paraffin wax is a white or colorless soft solid derivable from petroleum, coal or oil shale, that consists of a mixture of hydrocarbon molecules containing between 20 and 40 carbon atoms. It is solid at room temperature and begins to melt above approximately 37 degrees Celsius. Its boiling point is greater than 370 degrees Celsius. Common applications for paraffin wax include lubrication, electrical insulation, and candles. It is distinct from kerosene, another petroleum product that is sometimes called paraffin. In chemistry, paraffin is used synonymously with alkane, indicating hydrocarbons with the general formula CnH2n+2. The name is derived from Latin param plus affinish, meaning lacking affinity, or lacking reactivity, referring to paraffin's unreactive nature. Properties. Paraffin wax is mostly found as a white, odorless, tasteless, waxy solid, with a typical melting point between about 46 and 68 degrees Celsius, and a density of around 900 kilograms per cubic meter. It is insoluble in water, but soluble in ether, benzene, and certain esters. Paraffin is unaffected by most common chemical reagents but burns readily. Its heat of combustion is 42 kilojoules per gram. Paraffin wax is an excellent electrical insulator, with a resistivity of between 1013 and 1017 ohm-meter. This is better than nearly all other materials except some plastics. It is an effective neutron moderator and was used in James Chadwick's 1932 experiments to identify the neutron. Paraffin wax is an excellent material for storing heat, with a specific heat capacity of 2.14–2.9 Jg–1 K–1 and a heat of fusion of 200 to 220 Jg–1. This property is exploited in modified drywall for home building material. A certain type of wax is infused in the drywall during manufacture so that it melts during the day, absorbing heat, and solidifies again at night, releasing the heat. Paraffin wax phase change cooling coupled with retractable radiators was used to cool the electronics of the lunar rover. Wax expands considerably when it melts, and this allows its use in wax thermostatic element thermostats for industrial, domestic and, particularly, automobile purposes. Manufacturing. The feedstock for paraffin is slack wax, which is a mixture of oil and wax, a byproduct from the refining of lubricating oil. The first step in making paraffin wax is to remove the oil from the slack wax. The oil is separated through crystallization. Most commonly, the slack wax is heated, mixed with one or more solvents such as a ketone, and then cooled. As it is cooled, wax crystallizes out, leaving oil in solution. This mixture is filtered into two streams, solid and liquid. After the solvent is recovered by distillation, the resulting products are called product wax and foots oil. The lower the percentage of oil in the wax, the more refined it is considered. The product wax may be further processed to remove colors and odors. The wax may finally be blended together to give certain desired properties such as melt point and penetration. Paraffin wax is sold in either liquid or solid form. Applications. In industrial applications, it is often useful to modify the crystal properties of the paraffin wax, typically by adding branching to the existing carbon backbone chain. The modification is usually done with additives, such as either copolymers, microcrystalline wax, or forms of polyethylene. The branched properties result in a modified paraffin with a higher viscosity, smaller crystalline structure, and modified functional properties. Pure paraffin wax is rarely used for carving original models for casting metal and other materials in the lost wax process, as it is relatively brittle at room temperature and presents the risks of chipping and breakage when worked. Soft and pliable waxes, like beeswax, may be preferred for such sculpture, but investment casting waxes, often paraffin-based, are expressly formulated for the purpose. In a pathology laboratory, paraffin wax is used to impregnate tissue prior to sectioning thin samples of tissue. Water is removed from tissue through ascending strengths of alcohol and the tissue is cleared in an organic solvent such as xylene. The tissue is then placed in paraffin wax for a number of hours and then set in a mold with wax to cool and solidify. Sections are cut then on the microtome. Other uses: candle making, coatings for wax paper or cloth, food-grade paraffin wax. Shiny coating used in candy making. Although edible, it is non-digestible, passing right through the body without being broken down. Coating for many kinds of hard cheese, like Edam cheese. Sealant for jars, cans, and bottles. Chewing gum additive. Investment casting. Anti-caking agent, moisture repellent, and dust binding. Coatings for fertilizers. Agent for preparation of specimens for histology. Bullet lubricant, with other ingredients, such as olive oil and beeswax. Phlegmatizing agent, commonly used to stabilize, desensitize high explosives such as RDX. Crayons. Solid propellant for hybrid rocket motors. Component of surf wax, used for grip on surfboards in surfing. Component of glide wax, used on skis and snowboards. Friction reducer, for use on handrails and cement ledges, commonly used in skateboarding. Ink, used as the basis for solid ink. Different color blocks of wax for thermal printers. The wax is melted and then sprayed on the paper, producing images with a shiny surface. Micro wax. Food additive, a glazing agent with number E905. Forensic investigations. The nitrate test uses paraffin wax to detect nitrates and nitrites on the hand of a shooting suspect. Anti-ozonant agents. Blends of paraffin and micro waxes are used in rubber compounds to prevent cracking of the rubber. The admixture of wax migrates to the surface of the product and forms a protective layer. The layer can also act as a release agent, helping the product separate from its mold. Mechanical thermostats and actuators, as an expansion medium for activating such devices. Potting, guitar pickups, which reduces microphonic feedback caused from the subtle movements of the pole pieces. Potting, of local oscillator coils, to prevent microphonic frequency modulation in low-end FM radios. Wax baths for beauty and therapy purposes. Thickening agent in many paintballs. Moisturizer in toiletries and cosmetics such as Vaseline, though potentially comedogenic. Prevents oxidation on the surface of polished steel and iron. Phase change material for thermal energy storage. Manufacture of boiled leather armor and books. Skateboard wax. Paraffin microactuator. Neutron radiation shielding. Occupational safety. People can be exposed to paraffin in the workplace by breathing it in, skin contact, and eye contact. The National Institute for Occupational Safety and Health has set a recommended exposure limit for paraffin wax fume exposure of 2 mg per cubic meter over an 8-hour workday.